Hi, welcome to our 7th training session, where we will demonstrate how to configure the 10-bit digital to analog converter to output a positive ramp. Any embedded system project involves 3 important steps. The first step is to select embedded C as our programming language. The second step is to procure LPC2148 based evaluation board and a digital multimeter for measuring ramp voltage. Programs written in C are readable and easy to debug. To debug embedded C program on the PC, we use a simulator. We use a Jaguar debugger to download and test the program running on the target hardware. LPC includes a 10-bit DAC, and the analog output is made available on port pin P0.25. The demo board brings out this DAC pin on a Berg stick and name it as DAO pin. LPC 10-bit DAC can have 1024 possible analog output voltage values. In this lab, we configure port pin P0.25 as an analog output pin. All C programs starts from main. In our first function call, we initialize general purpose port pins. We configure first 16 pins of port 0 as output. In the second function call, we initialize timer 0 and generate timer interrupt every 1 millisecond. We will be using a digital multimeter to measure output voltage on a Berg stick, make DAO. Hence the third function call, initialize DAC, we configure port pin P0.25 as analog output. The while one loop increments a 10-bit counter and outputs this value to the DAC. The delay between each DAC output updates is defined by a constant named delay DAC. On reset, all port pins are configured as input. Hence in the first function call, initialize LPC, we set the port direction of first 16 bits to be output. As we know, 16 pins can be used to drive 7-segment display or a LCD module. The second function initializes the timer for generating 1 microsecond interrupt. The clock for the timer module is from the 4 MHz peripheral clock. We generate a 1 microsecond interrupt by programming the match register MR0. The crossware wizard computes the values to be loaded into the MR0 register and generates the code for resetting the timer counter and also generating timer interrupt. The vector interrupt controller is programmed with slot 0 for timer 0 interrupt and the vector address pointing to timer interrupt subroutine. In the timer interrupt subroutine, we very well know the time interval is 1 millisecond. Hence we decrement all time-dependent variables. We enable timer for the next 1 microsecond interrupt by clearing the match 0 bit set in the IR register. Similarly, we signal the VIC end of timer routine by a dummy write to the vector address register. LPC2148 has on-chip DAC peripheral, which has 10-bit resolution for generating a precise analog output voltages on a physical pin. The 10-bit DAC output voltage range is from 0 volts to a maximum of applied reference voltage in 1024 equal steps. Hence the first step is to configure the pin select 1 register to make P0.25 pin as a special function DAC output. The DAC conversion starts the moment we write into DAC register. The DAC register is 32-bit wide. The 10-bit digital value needs to be shifted by 6 bits before writing into the DAC register. As we are generating A ramp waveform, we reset the DAC count variable the moment it reaches a hexadecimal count of 400. So the analog output voltage rises from 0 to a maximum of 3.3 volts before dropping down to 0 in 1024 steps.